Aren't you?
Yeah.
Okay, perfect. So here's something we haven't looked at much yet. If we have a room that is 9 foot 3 inches by 12 foot 8 inches, how do we find the area of the floor of that room, assuming that's a rectangle? Well, if you recall, when we talked about multiplying with measurements, we multiplied by a scalar, which meant we could take that measurement in feet and inches and multiply by just a whole number, a counting number. But if we were multiplying two measurements, we either need it all in feet or all in inches. In construction, especially when we're dealing with the floor area, there's not really many applications where square inches would be of much use to us. So square feet is probably where we're going to go with this. Think of square feet, you'd be looking at square feet of carpeting or other flooring or any sort of a subfloor that would be going down. So let's try to get these dimensions in feet. How do we take 9 feet 3 inches and put it into just feet? Well, we're going to end up using fractions, and the way we're going to do it is remembering that 3 inches, there's 12 feet in an inch, so 3 inches is just 3/12 of a foot. So that is 9 3/12 of a foot. Now, of course, 3/12 can be reduced to 1/4. So that is 9 1/4 feet. Now we have to do the same for the 12 foot 8 inches. So 12 foot 8 inches, if we have to put that into just feet. Again, 8 inches, if there's 12 inches in a foot, is 8/12 of a foot. And that can be reduced, of course, to 2/3. So what we really have here for an area is we have 9 1/4 feet by 12 2/3 feet. Now my calculator doesn't have fraction functions on it, so I'm going to do that out by hand. So 9 times, remember when we multiply mixed numbers, we have to turn them into improper fractions. So we're going to do 9 times 4 is 36, plus 1, that is 37/4. 12 times 3 is 36, plus 2 is 38/3. Do I have to flip the second one over? No, I don't. When we're multiplying, we don't have to do the reciprocal. It's when we're dividing that we do the reciprocal. I can cross-cancel here, cross-multiply. My 4 and my 38 can both divide by 2, so that gives me 2 and 19. 37 divided by 19, I believe, is 703. And 2 times 3 is 6. And now it's a matter of reducing that back into a mixed number. So we're taking the 703 divided by our denominator of 6. 6 goes into 7 once. That's 6 with 1 left over. Bring down the 0. 6 goes into 10 once. That's 6. 10 minus 6 is 4 left over. Bring down the 3. 6 goes into 3 7 times. 7 times 6 is 42, so there's 1 left over. Nothing left to bring down, so the 1 goes over 6. So 117 and 1/6 square feet is our area. We might run into a triangle set up like that. So if we need to find the area of a triangle that is 8 feet 6 inches by 12 feet 9 inches, 8 feet 6 inches is going to be what if we take it just to feet? 8.5. Very good. How about 12 foot 9 inches? 12 and 3/4. Very good. At this point, hopefully you're starting. That should be feet, not inches. At this point, hopefully you're starting to notice that 3 inches is 1/4 of a foot. 6 inches is 1/2 a foot. 9 inches is 3/4 of a foot. It looks like you're getting that down. The other ones that you should get used to also is the 4 inches being 1/3 of a foot and 8 inches being 2/3 of a foot. Those are ones that come up often enough to be handy to have those at the top of your head, ready to go. So the area here, 8.5 feet times 12 3/4 feet. You got to remember to divide by 2. So this is going to be a little bit trickier. We're still going to make these into mixed numbers. Or improper fractions, I should say, not mixed numbers. 8.5, 8 times 2 is 16, plus 1 is 17 halves. Times 12 times 4 is 48, plus 3 is 51 over 4. Still going to be over 2. Can't cross cancel anything here. So we got 17 times 51. 867 over 8. Now that's being divided by 2. So divide a fraction by 2. I'm going to leave it as an improper fraction for now. We're dividing by 2, and I have to make that a fraction by making it 2 over 1. So that's going to become, just like we would with any other fraction, 867 over 8, instead of divided by 2 over 1, it's going to be times 1 over 2. So that's going to be 867 over 16. Now we can go ahead and split that back down into a mixed number. So 16 goes into 86 5 times. That's 80 with 6 left over. Bring down the 7. 16 goes into 67 4 times. 4 times 16 is 64. There's 3 left over. So 54 and 3/16. And remember, that is square feet. That was feet times feet. One for you guys to try. So this is a trapezoid here. 3 feet on top. 9 foot 6 inches on bottom. 11 foot 3 inches tall. So I want you guys to find the area. I'll give you a couple minutes to try that in your notes. Okay, let's take a peek at how you're doing. So 3 feet, of course, is just fine the way it is. 11 foot 3 is 11 and 3/12. Perfect. Now reduce to 1/4. So 11 and 1/4 feet. Perfect. Then 9 foot 6 becomes 9 and 6/12, or 1/2 feet. Perfect. Now when we go to find the area, when we're doing the area of a trapezoid, it's the average of the bases. Which two are we going to average together here? Which two are the bases? Yeah, the 3. Perfect. The 3 and the 9.5. So 3 plus 9.5 over 2 times the 11 and 1/4. So 3 plus 9.5 is going to be 12.5 over 2 times 11 1/4. Now I'm going to let you guys verify the division here. 12 1/2 divided by 2 is 6 1/4. Perfect. Then somebody want to tell me what 6 1/4 times 11 1/4? Careful, you added them. 66 1/2 won't quite be it.
70 5/16.
Perfect. There it is, 70 5/16. That is square feet. Okay. Now, some of the things we did now then, we've gone into the three-dimensional. We've talked about volumes and surface areas, and we've done several volumes and surface areas. We've defined our volume as the area of a base. So this is a rectangular base here. Let's call this 16 inches by 12 inches times a height. Let's call this height here 15 inches. So we're going to treat this bottom, now being a box, pretty much, as we've said before, since this is a box, any side could be considered the base. We're just going to use the bottom. So for volume, whether we're doing volume or surface area, the first step is going to be to find the area of the base. This is a rectangular base, so what do we do to find the area of this base? What do we use for the area to find the area of the base here? The base is this rectangle. Area of rectangle is length times width. So what are we going to multiply?
16 times 12.
There we go. Thank you. 16 times 12, or 192 inches square. So that's the area of our base. We're going to use that for a couple of different things as we finish off this problem. For volume, we take that area of the base, 192 square inches, and we're going to multiply it by what?
15.
Our height of 15 inches. Perfect. So 192 times 15 is 2880. So 2,880, that is inches cubed. That's our volume. Now the second place we're going to use that area of the base is when we start talking about surface area. For this one, the area of the base of 192, is it going to be added in once or twice? Do we have to put it in there a second time?
Yes.
Yes, we do, because there's not only a base on bottom, but there's a matching one on top. So then the other component of our surface area is going to be the lateral area, which we have to find. What two things do we need to know to find the lateral area? Perfect. The height, and not the length, but the perimeter of the base. There, I heard somebody say it. So we know the height is the 15. We just have to find the perimeter of the base here. The perimeter of the base is just the 16 plus 12 plus 16 plus 12, which is 56 inches. So our lateral area is the 56 inches times the 15 inches of height, which is 840 inches squared. So that means our total surface area is found by adding those up. So what, 4, 18, 22, 12. So 1,224 square inches is our total surface area.
What is the lateral area?
The lateral area, very good question. Lateral area is the area of the sides connecting the bases. Well, what does that mean? Okay, so on a figure like this, we've got a base on bottom. And I'm going to cheat. And we have a matching base on top. So those are the area of our bases. The lateral area for most figures are these rectangles that connect them. So you got one there, you've got one here, you've got one in back, and you've got one over here. Well, the reason we find it the way we do is we can slice that up one of the corners. We can unroll this around the figure. So this is going to be a rectangle. This was 16, 12, and 15. This piece is going to be 12 feet here by 15 feet high. The next piece as we unfold is going to be this back piece is going to be here. Still 15 feet high by 16 feet. And then this piece over on this side, 12 feet by 15 feet high. And then this front piece, 16 feet by 15 feet high. So what we see is we can take that whole lateral area, those four sides that connect the bottom to the top, to connect the two bases, and we can fold it out into one big rectangle. And the height of that rectangle is still just the height of the figure. The length of that rectangle is just the perimeter of the base. So that's why lateral area is just the perimeter of the base times the height. And the reason we define it that way, instead of just finding, because we could easily find the area of those four rectangles and just add them together. But the reason we did it that way is so that when we run into a cylinder like this, it's the same concept. Let's say this is 10 feet here and 15 feet tall. And pretend this looks like a cylinder and not some smashed, half-smashed pop can. So to find the surface area, it's the same process. It's the area of the base. Well, for this one, the base is a circle, so we have to have that 5-foot radius. So the area of that base is pi times 5 squared, which would be 78.5 square feet. And then we've got a second one up top, of course. Up here is going to be identical. So a second area of the base of 78.5 square feet. The lateral area isn't as obvious here. But if you take this and you cut it down the side and unroll this, kind of like taking the label off a soup can, you'll see the same thing there. That's going to unroll. Its height is still going to be 15 feet, the height of the can, and the distance around is going to be this distance around the bottom of the can, or the top of the can. That's going to be the perimeter of the base again, which is the circumference of that circle, which is pi times 10, or 31.4 feet. So the lateral area is 31.4 for the perimeter of our base times 15 giving us 471. So total surface area here kind of sounds painful, doesn't it? So our surface area is 628. Okay. Sorry, I shouldn't laugh at that, but
It's Friday, right?
it sure is. Okay, so another reason we've defined things the way we have is we can run into shapes that are more complicated than what we've been dealing with. You can run into a shape like this. So here, this shape, let me label everything out here. Let's say that this is 20 feet. We're going to go 20 feet of height here. And we'll go let's go a nice even 16 feet here to keep it easy on us. And I want to find volume and surface area. Well, the first step is still going to be finding the area of the base. The base of this is a rectangle with a half circle on the end of it. So we can find the area of the rectangular portion, I'll call that piece 1, is just 20 feet by 16 feet. 320 square feet. Piece 2 here is a half circle. That area is pi times, what's its radius? What's its diameter? Diameter 16, so the radius would have to be 8. Very good. So pi times 8 squared and then divided by 2. So that's going to be what? 100.48 square feet. So that adds up to the area of the base being 320.48 square feet. So now that we have that, our volume is pretty simple to find again. Our volume is that area times 20 feet. Yeah, we can do this. So 6,409.6 cubic feet of volume. For the surface area, we're going to use the area of the base. So the 320.48 square feet, and there's a base on top, 320.48 again. And then we have to find the lateral area. Find the lateral area, of course, we need the perimeter of the base again. So, (16 feet by 20 feet). Our perimeter is going to be 20 plus 16 plus 20 plus whatever that length is around there. That is half of a circle, so we're going to find the circumference of the whole circle. Pi times what? This diameter for this one, for circumference. So that would be what number? 16. Very good. Now since it's half a circle, it's divided by 2. That gives us 25.12 feet. So that tells us our perimeter here is what? 40, 56, 61, 81.12 feet. So our lateral area can be found 81.12 feet times that, was it 20 feet of height? Yes, it is. 20 feet of height. So that's going to give us 1,622.4 square feet of lateral area. So again, what that is, that's representing all these sides. We've got the base down there and the base on top. This is representing all these sides that wrap around. So that's this rectangle on front, this curved piece on this end, the rectangle on back, and then the rectangle on the left side as well. So now we add those all up. The total surface area is 2,263.36 square feet. Can anybody remember the formulas for volume and surface area of a sphere? Volume is kind of a weird one. The volume is 4/3 times pi times radius cubed. So here, since I'm giving you a radius of 12 feet, that'll be 4/3 times pi times 12 cubed. I ain't even going to try that one without a calculator. 4 divided by 3 times, I'm just going to use 3.14 for pi again, times 12 cubed we know is 1728, but we'll let the calculator do the work. 7234.56. So the volume is 7,234.56 cubic feet. Surface area. I think I heard somebody saying this formula earlier. It's 4 times pi times radius squared. So 4 times pi times 12 squared. Hang in there, guys. Week's almost over. 1808.64. That's going to be square feet. So these spheres can come into play partially. Let's look at a silo here. Now we are going to assume that you can fill this silo all the way up to the top. I realize that the very, very top of the sphere up here is probably not going to get filled, but we're going to make the assumption that you can fill it all the way up to the top. So if we have a 20-foot wide base and a 40-foot tall silo, let's find the total volume. Well, this looks like a difficult task, but it really isn't that bad. It really is just a cylinder. It's 20 by 40, and then half of a sphere. It has a diameter of 20. So let's do the cylinder first. For the cylinder, we're going to start out with the area of the base. What do I do for the area of the base? Pi times what?
Pi times radius squared.
Pi times radius squared. What's my radius going to be here? 10. Perfect. So pi times 10 squared is 314 square feet. So then what do I do with that to find my volume? Volumes are 314 square feet times what? Times, that's the area of the base. So to get the volume, it's times this dimension, which will be the height of 40. There you go. So that is 12,560 cubic feet of volume. Now we've got to do the sphere. Now remember, the volume of a sphere is 4/3 times pi times radius cubed. Well, the radius for this sphere is going to be the same as the radius for our circular base. It's going to be 10 feet. So this is times 10 cubed. But is it a full sphere? No, it's only half a sphere. So we got to divide it by 2. So 4 divided by 3 times pi, 3.14, times 10 to the power of 3 divided by 2. Oops. Got to be careful there. Power of 3, and I got to arrow out in my calculator to get divided by 2. 2093.33. That is cubic feet. So I have to add those two together. So I'm going to bring this one down. 12,560. So I've got 3, 3, 3, 15, 6, 4. So 14,653.33 cubic feet of total volume in that silo. Okay. This next problem I'm going to do is actually part of a quiz you're going to get. Mr. Berghammer, are you in the room there?
Yeah.
Yeah. Do you want to go ahead and just give them both of the quizzes? Yep, we've got the one that we didn't have ready on Wednesday for you, so we'll get that one to you. Both of these quizzes, by the way, you get to take home over the weekend and work on. So these are both take-home quizzes.
You want me to hand each of them a copy of both, correct?
Yep, both of them. Okay, so what we're going to look at, the first quiz, if you look at it, it's the quiz 7, 10-4, should look awful similar to some of the stuff we did in class on Wednesday. We did a problem like the countertop. We did a problem similar to that roof problem. We also did one, we actually did number 8 in class, so if you have notes, you can find that one. And we did a pond problem, a deck around a round pond, like in number 9. What I want to do together here now is on the second quiz, the quiz is also quiz 7, but it's 10-11. The very bottom of that one, there's a house. And I'm asking you some questions about that house there, and I want to go through that together right now. So we're going to see if I can draw this somewhat respectably. Okay, so what we have here is this is a hip roof on the main part of this house. And what's sticking out here is often called an L. The L over here has a gable roof on it. So I'm actually going to erase this line here. So you have the gabled roof on the L. So we want to first find the area of that roof. We have 32 feet here, 16 feet, 38, 32. And we're given 54 feet is the edge of the roof. So we got to be careful. That's this roof edge here. We're also told that there's 1 foot overhangs on the whole house. So what that means is the roof, if you're looking at it from the end, the roof actually hangs over 1 foot on each side all the way around. Oops. Hopefully it's a little bit straighter than that. So what that means here is if this is 54 feet, that back wall is only 52 feet. So anyway, what we have is we're looking at this piece on front here. Stick with me, guys. If the wall is 32 feet and we have a 1 foot overhang, what's this dimension across here going to be? 34, right? 1 foot overhang on each side, so adds 2 feet to it. Now over here, on the gable end, again, this is going to be 30 feet, 4 feet across, because there's a 1 foot overhang on each side. I tell you that this common rafter here is 18 feet long. So that's just the distance from here up to there, the right angle on both ends. Now the thing is here, since this is assuming that the whole roof is the same slope, that 18 feet is going to be the length everywhere on this roof. So to give you an example here, this triangle that makes up this gable end is going to be 34 feet by 8 feet, or 18 feet, I should say. So you can find the area of that triangle like that. So that's one of the pieces you'll have to find. This triangle over here is the exact same piece. So there's 2 of those. The back side of this is a trapezoid. That trapezoid on bottom is 54 feet. We know this height is 18 feet. We have to find the length of the top of that trapezoid. That'll be the length of the ridge up here. Well, the length of that ridge is going to be the 54 feet minus a setback on each end. Well, that setback here, this distance, is going to be equal to half of the whole span. If that's 34 feet, this will be 17 feet. So what that means is we're subtracting 17 feet off of each end. So 17 and 17 is 34. That means that ridge is 20 feet long. So you have to find that area. There's another trapezoid right here. I'm going to draw it out. We know once again this is 18 feet going up. We got to find the length on bottom. Now this is 38 feet here. Do we have to add a foot for the overhang? This is actually kind of a tricky question. If we're looking at the house from this end over here, you've got this overhang here, then this roof here comes up, and that also overhangs a foot. But what happens is you got the 1 foot overhang here and the 1 foot overhang here cancels each other out. So this 38 feet just kind of slides over. So this is still 38 feet on this edge of the roof. So that bottom's 38 feet. The top, well, is that same 17 feet across here gets added in on the ridge. So we're adding 17 feet here. 38 plus 17 is 55 feet. So we have that trapezoid defined. And there are 2 of those. Because the other side of the L roof here is exactly the same shape. Next, we have this shape right here. That should be a parallelogram. It's going to be 16 feet here. Again, the 1 foot pushes out over here, cancels out the 1 foot overhang on the end. So our parallelogram is 16 feet here, and it is still 18 feet of height. So we find that area. And there's only one piece left. That's this little piece over here. We said the roof edge was 54, which makes the whole building 52. So we've got 16 and 32 add up to 48. 52 minus 48 means 4 feet is what's left over here. That's a 4 foot parallelogram. So that's 4 feet here, and again, 18 feet of height. So we'll find that area. Let's do the triangle here since that one's pretty easy. How do I find the area of a triangle? Come on, guys. This triangle right here, how do I find its area? Careful, 34 times 18. Yep, then divided by 2, right? Now there's 2 of them, so we're going to multiply it by 2 once we get that answer. So 34 times 18 divided by 2 is 306. Times 2 is 612. So 612, that's square feet. So that's that piece. How about this trapezoid here? Trapezoid is where we do what? Okay, careful, 20 plus 54 divided by 2, and then times what?
17.
Careful. Times 18. There you go.
Thank you. Thank you.
So what is that? 20 plus 54 divided by 2 times 18 is 666. Come on. There it goes. 666. I was right. Okay, so 612, 666. How about for this trapezoid? What two sides are we going to add here? Yeah, technically that's not 15. That's a... My marker just didn't work. My pen just didn't work. That's actually 55. Times 18. Perfect. We get 837. This parallelogram down here is actually simple. What do we have to do for that? Do we have to divide it by 2? No, because it is a full rectangular shape. If I cut off this end, it fills out the rectangle there. So 16 times 18 is 288. Nice try, though. And then this last parallelogram is 18 times 4. Good. 72 square feet. So that comes up to, if we add that up, what is that? 360, 1197. Oh, crap. 1278. So that is what, 15, 17, 2475 square feet is the area of that. Now, when we talk about roofing, guys, we have the square feet, 2,475. So when you talk about roofing, you talk about roofing by the square. A square is a unit that is 10 feet by 10 feet. In other words, 10 times 10 is 100 square feet. So when you're dealing with roofing, to convert it to a square, you take the square footage divided by 100 square feet. It's going to give you 24.75 square. When you order shingles or other roofing material, that's how you generally order it, is by the square. The next part of this problem is to calculate the siding. I'm going to sketch this out without the roof on it quick. Okay, for siding, except for one extra piece, the siding of this is just a lateral area. So I can find most of the area of siding for this house by doing the lateral area formula, which is perimeter. So I'm going to find the perimeter of the base here. So the perimeter of this house is 32 feet here, plus 16 feet here, plus 38 feet there, plus 32 feet there, plus over here is another 38 feet. We have to assume, we can't see it, but we have to assume it's 38. Plus, we calculated this piece over here before to be 4 feet. Plus, on the back side here, we're assuming another 32. Plus, We said this was the 54 of the ridge minus a foot on each end, so 52 feet. So if we add all that up, we got
32 plus 16 is 48 plus 8.
that would be 86.
86 plus 32 equals 108.
18, yep. We're 118 to this point. You were off by 10, but that's good. Good job. 118 plus 38.
156 plus 4 160.
Yep.
172.
Careful.
192.
192 plus the 52. 244. Perfect. So the perimeter of this is 244 feet. And we're showing a wall height here of 9 feet. So we're going to get a lateral area of 244 feet times 9 feet of wall height. Now I'm assuming what that is 8-foot ceilings inside plus a 12-foot floor thickness if you have a 2 by 12 or 2 by 10 floor joists with whatever floor thickness you have on there. Probably 2 by 10 floor joists if you're assuming 12 inches of thickness. But so we're assuming that that's also covering that floor thickness. So 244 times 9, 2196 square feet. Now there's one little piece. Can anybody figure out what little piece I still have to add? There's this little triangular gable over here that I have to add. And if I look at that, there's a 1-foot overhang, so it actually is 34 feet here, and the height is given as 6 feet tall. So I have to add the area of that is 34 feet times 6 feet tall divided by 2 because it is a triangle. What's that give us? 102 square feet. So that is 2,298 square feet of siding. Now, a lot of times you order siding by the square as well. So we could do the same thing we did with our roofing and divide by 100 to get 22.98 square of siding. In this case, I had just asked for the square feet of siding. Okay, these last two problems both deal with volumes. They're requiring us to find the volume inside the house. Now it says they're assume flat ceilings, which makes this a lot easier. We don't have to find the volume up in the attic of the sloped roof. So we're going to find, again, finding the volume of this isn't bad using our formulas where it's area of a base times the height. Let's look at the base. This is 52, 32, 16, 38, 32, 32, 4, and 32. Actually, this one here is 38, isn't it? Well, the area of the base of this is just two rectangles. What's this first rectangle? How do I find its area? Yep. Perfect. 52 times 32. So it's 1664. And then piece 2 here is perfect. 32 times 38. Which is 1216. So that adds up to 2,880 square feet of floor area. That's the area of the base. Now remember I said that we're assuming a 1 foot floor thickness. So this is 9 feet total height, and we're assuming a floor thickness of 1 foot. That makes the ceiling height 8 feet. So to find the volume of this house, assuming flat ceilings, we're just taking that area of the base, the 2,880 square feet, times the ceiling height of 8 feet. Gives us a volume of 23,040 cubic feet. Now, minimum rating for heating is 2 BTU per cubic foot. Most places would say a minimum of 3 to 4 BTU, but absolute minimum is 2 BTU per cubic foot. So minimum BTUs, oops, go ahead. Yep, BTU stands for British Thermal Unit. Why British? I don't know, that's just where we adopted it from, and we haven't switched over. If you get into the metric system, they deal with calories, and I can't remember what the bigger unit is they use for home heating, but this is the old standard unit. So we take our area of 23,000, a volume of 23,040 cubic feet times 2. It gives 46,040 BTU is the required furnace size. Now most houses are around 90 BTU furnaces. Why would we need a 90 BTU furnace for this? I said most places will say 3 to 4 BTUs per cubic foot. The main reason for that is we didn't account for the possibility of this house having a basement. So that extra BTUs is for the basement that's going to be under a lot of these houses. Okay, now for the rest of these quizzes, like I said, you guys can take them home over the weekend and work on them. But I would like you to spend the last 25, 30 minutes here of class working on them as well. I do want to give you one more hint on the quiz. This is on numbers 5 and 6 on that same quiz. It's the quiz 7, 10-11. This is a triangular object here that you're trying to find volume and surface area. The surface area is actually fairly easy once you find the area of the base. The problem is this is your base down here, this triangle. Well, it's not a right triangle. We have sides here of 6 inches, 8 inches, and it says 7 inches up here. Well, that means 7 inches right here. To find the area of that triangle, you're going to have to use Huron's formula. So that's where you're going to find the perimeter. Now, once you find that perimeter, remember you can use that. That's the perimeter of your base. You'll use that for finding lateral area later. So find that perimeter, then the semi-perimeter. And remember, the area is the square root of that semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Okay, we have 27 minutes left in class. I want you guys to spend the time working on those two quizzes. If you guys have any questions come up, give me a yell. I'll still be here. So.